Good morning, everybody. My name is Dr. Alvaro, and in this video, I will teach you how to construct indirect truth tables. In my previous video, I taught you how to construct traditional truth tables. A truth table is a mathematical table that logicians use to determine the validity of deductive arguments. Recall that an argument is valid if and only if, given the premises, the conclusion must follow necessarily from the premises. Or another way to put it is that an argument is valid if the premises are true and it is impossible for the conclusion to be false. Consequently, an invalid argument is an argument that can have true premises and still can have a false conclusion. So when we constructed traditional truth tables, if you recall, we were looking for precisely that pattern. What I'm referring to is a pattern where there's a combination of truth values where the premises are true and the conclusion false. So a quick review of traditional tables. If you recall, the traditional table, I used this argument in my previous video. If it rains, my car is wet. My car is wet, therefore it rains. You set up the argument this way, and then you list all the truth values for each statement, for each term. And remember that we always begin with the far left term right here, the first term on the left, in this case R, which represents it rains. And the rule says that for the second term, if it's different from the first one, like in this case we have W, we have to double the truth values like so. So we have 2 T's and 2 F's. If I had yet another term right here after the W, I would have to double again. So I would have to list 4 T's and 4 F's. Okay, so in this case, then what we do is we list all the truth values. Notice that the W here in the second premise is the same W that occurs in the first premise. Consequently, what I have to do, the only thing to do is to transcribe all the truth values that are here underneath this W, and I just transcribe them underneath the second premise because it's the same term. And the same thing applies to R in the conclusion. It's the same R that occurs in the first premise. So it's going to have the same truth values. The last thing that I have to do is to find the truth values for the compound statement, because this is is a conditional statement, if then. And if you remember, the rule says that the only possible combination that renders a conditional statement false is only if the antecedent is true and the consequent false, like in this case in the third row. Any other combination, the statement is true. So remember that at this point, with a traditional table, we would have to look at each row and try to find that pattern, okay, where the premises are true and the conclusion is false. And lo and behold, that it is in the second row. See, so there is a combination in this argument where the premises can be true and the conclusion false. But an argument that can have true premises, and despite the truth of the premises, the conclusion can still be false, is an invalid argument. That's how we recognize it. Now, the indirect version of this works differently. So how does it work, the indirect truth table? First of all, we don't need to list all the combinations, all the truth values. And we don't start from the far left, but we start with whatever we know. Recall that the idea of an invalid argument is that the argument is invalid if the premises can be true and still the conclusion can be false. So the way the indirect version of the table works is, for some people might sound strange, because the way it works is that we try to confirm. With the indirect version, you try to confirm invalidity. Okay? So if the argument is invalid, you will be able to confirm invalidity. In other words, true premises, false conclusion. On the other hand, if the argument is valid, then you will not be able to confirm the invalidity, which is, once again, true premises and false conclusion. But remember, this is very important. There's only one combination that renders an argument invalid. And that combination is that all the premises are true and the conclusion false. If one of the premises is false and the conclusion is false, it's not going to work. Okay? So let's see how it works. Okay, so I start with a conclusion because I know that the conclusion must be false. And now I know that R is false. Then the second premise, the W, is true. So now that I know the truth values of W and R, I just plug him in. W is true and R is false. Okay? So am I able now to confirm the invalidity of this argument? I think so, because if you remember, the rule for the conditional statement says that if the antecedent is false and the consequent is true, it renders the statement true. Then the second premise is true and the conclusion false. And that means that the argument is invalid. It's invalid because, again, I was able to confirm this pattern here. All premises true, conclusion false. What would it look like if the argument was valid? Well, let's look at a valid argument first. And once again, let's look at how it works on a traditional square. Square of opposition is something else. Traditional tree. So in a traditional tree, once again, this argument is similar. We just flipped switched the second premise in the conclusion. So we assign all the truth values, true, false, true, false, true, true, false, false, same as before. And we find the truth values of the conditional statement. Okay. At this point, we focus on these three columns and we try to find a row that indicates true premises and false conclusion. But as you can see, none of the rows indicates true premises and false conclusion. The third row, notice that the first premise is false, second is true, and conclusion false. But again, it doesn't work because, as I said, the only combination that renders an argument invalid is only if the premises are both true and the conclusion false. So that tells us that the argument is valid. Now, let's do the indirect version. W is false, we know that. And so I plug in the truth value of W. R must be true. If I want to confirm the truth, I have to say that it's true. So if R is true, then when I plug in here, watch what happens. Remember that, once again, the rule for the conditional statement is that a conditional statement is false only as a result of one particular combination. The combination is only one, namely this one, where the antecedent is true and the consequent is false. And that renders the conditional statement false. So what does that mean? It means I was not able to confirm the falsity. I'm sorry, not able to confirm the invalidity of this argument. Or to put it another way, I was not able to confirm the truth of the first premise, because the first premise, as you can see, given the combinations, is rendered false. And a false, true, false indicates that the argument is valid. All right. Let's move on to a more complicated example. Notice that this argument has 3 premises and 1 conclusion. So it has 4 statements total. What do we do first? Once again, we start with the conclusion. Now, the conclusion must be false. How do I make the conclusion false? Notice that the conclusion is a negation. Okay? So if not C is false, what does that mean? It means that C is true, because the negation makes it false. So now I know that C is true. Okay? The next thing is the H. Very simple. It's a simple statement, so I can confirm that H is true. And now I'm going to have to plug in the H. At this point, however, I ask myself, what do I do with P? Because there's no indication as to whether P is true or false. So in this case, what I do is I do a trial, a couple of trials. The first one, I just I just decide either true or false. Okay, it's just an arbitrary decision. And in this case, let me choose that P is true and see what happens. And then later we have to consider whether if I said that P is false, what would happen with the argument. But let's start with the true. So I'm going to be able very easily to confirm the truth of premise 2 because it's a conditional statement and both the antecedent and the consequent are true. That renders the statement true. And it's the same for premise 1 because this is a disjunction, and remember that the rule says that a disjunction is false if and only if both disjuncts are false. But in this case, they're both true. Consequently, it gives me a true. And I was able to confirm once again the truth of the premises and the falsity of the conclusion. Now, remember that I said that this was an arbitrary decision to say that P is true. What would happen if P, that I said that P is false? Would it change the outcome? No, it wouldn't change the outcome, because think about it. If P is false, the conditional statement is still true, because when the antecedent is false and the consequent is true, the statement is true. Now, what about the disjunction? The disjunction will also be true, would still be true, even if P is false. Because remember that, as I said earlier, the only combination that renders a disjunction false is only if both disjuncts are false. So even if P is false, it doesn't change anything. The argument is still invalid. Great. Let's do yet a more complicated example. We still have 4 statements, 3 premises, and a conclusion. But this is a little bit more, challenging. Okay, so we always start with a conclusion. Because remember, what we're trying to do, once again, in the indirect truth tables, we always try to confirm, if we can, confirm the invalidity of an argument, which means we are trying to confirm that all the premises are true and the conclusion is false. So we start with the conclusion and we know the conclusion is false. Then we move down to backwards to premise 3. Premise 3 is a negation, not R. So if not R is true, it means that R must be false. Oh yes, I forgot to plug in the truth value for C. Okay, C was false. I forgot that. False and false. Okay, so now back to R. R must be false because its negation renders it true. Okay, so now I know that R is false. Wonderful. Okay, now when we move down to premise 2, notice that premise 2 is a compound statement made out of 2 terms. The first one is H, and the second one is a conjunction between P and C. Remember that the rule says that the only combination that renders a conjunction true is only if both conjuncts are true. Any other combination makes it false. Also, remember that this is a double conditional. Okay? If and only if, or material equivalence. Remember, the rule for material equivalence says that the statement is true if and only if both terms have the same truth values. So, what does that mean? It means that since I know already that the statement in the parentheses, the conjunction in parentheses, is going to be false, I'm going to say that P is false. Okay? And then I plug in the truth value for P right here in the first premise. So if if P is false, that the combination of false and false will render the statement inside the parentheses false. So if it's false, the conjunction is false, I know for sure that H must be false, because remember that premise 2 is a double conditional. And the rule, as I just said, is that you need both terms to be false, to have the same truth value in order for the statement to be true. And we want to confirm the truth of the statement, right? So H is false. So the falsity of H and the falsity of the conjunction in a parenthesis is also false. False and false renders the statement true. At this point, I find the truth value for the conditional statement inside the parenthesis in the first premise. But remember that the first premise is a disjunction. The first disjunct is P, the second is if R then C. And remember that the rule says that the only possible combination of truth values that renders the disjunction false is only if both disjuncts are false. But in this case, we have P is false and if R then C is true. And false and true in a disjunction render the premise true. And once again, I was able to confirm that it is possible that the premises are all true and the conclusion is false. So what does that mean? It means that the argument is invalid. All right now. What if... Now notice that in this argument, once again, I said that P was false. So what happens if I say that P is true? Let's see if anything changes. If P is true, then this statement here, the conjunction in the second premise, is still false, because remember that two different truth values in a conjunction renders the statement false. And it doesn't change the fact that premise 2 is true, because we have false here and a false H, and when a statement of this kind, double conditional, has both terms have the same truth value, it renders the statement true. Let's see if anything changes here in premise 1. So it doesn't change anything here, because remember that when the antecedent is false and the consequent false, that renders the statement true. And at this point, the disjunction would have both disjuncts true. And true renders the statement true. So even if I change the truth value of P, I still have an invalid argument, because I was able to confirm the pattern where all the premises are true and the conclusion can be false. Okay then, let's try another example. This is more complicated because notice that the conclusion is a conjunction. So I'm going to have some trouble, but not too much. I want to confirm that the conclusion is false. It's pretty easy. In a conjunction is false with several combinations. The only combination that makes it true is if both terms are true. So I will start by saying that they're both false. Okay, this is just an arbitrary decision. I say P is false, Q is false. Okay, and the falsity of both conjuncts renders the statement false. So at this point, I have to plug in all the values. P false, Q false. And once again, in a conditional statement, remember, premise 2 is a conditional statement. Conditional statement, if the antecedent is false and consequent is false, they render the statement true. What about the first premise? The first premise, we have P false and Q false. And in a disjunction, remember that when both terms are false, then the compound statement is false. Consequently, this didn't work. So I was not able to confirm this pattern here, true, true, false. However, should I stop here and declare the argument to be valid? No, I don't think so. Why? Because if you recall, I just made a stipulation. I said I am going to say that P is false and Q is false. But I could have made the conjunction false by saying that P is true and Q is false, or P is false and Q is true. Consequently, I have to do another trial. Let's do another trial. This time, P is false, Q is true. Okay? Once again, this makes the statement false. So this checks out. And at this point, I plug in the values for Q and the values for P. I know that Q is true and P is false. Now, look at the conditional statement in premise 2. The antecedent is false, the consequent true. So, it means that the statement is true. And for premise 1, since it's a disjunction, and a disjunction is false only if and only if both disjuncts are false. But in this case, one is true, one is false. Consequently, it gives me the truth value of true. And voila, this checks out. I was able to confirm that there is a combination where the premises can be true and the conclusion false. Therefore, this argument is invalid. Let's consider this interesting example. So, the conclusion here is a conditional statement. And the antecedent is negated. And remember that I want to confirm, I have to make this premise, this conclusion, the statement, false. So how do I make it false? Well, I need to say that the antecedent is true because, remember, in a conditional statement, the only combination that makes the statement false is if the antecedent is true and the consequent false. So that means that R, the antecedent, must be false because it's negated. And the negation of a false gives me a true. So I know that R is false and G is also false. But because R is negated, it becomes true. And there you go. And there I have that combination where the antecedent is true and the consequent false. And that makes my conclusion false. Okay, now I said that R is false and G is false. I plug them in. Now remember that I have to make the second premise true. Okay. But let's look at premise 1. Premise 1 can give us a clue because it's a disjunction. And I have the first term, the first disjunct is false. Consequently, I know that the second disjunct must be true, because if it's false, false and false, I'm not going to be able to confirm the truth of premise 1. So what does that mean? It means that L must be false. It must be false. Why? Because it's negated. So the negation of false gives me a true. And now I can have false the first disjunct and true the second disjunct. And false and true will give me a true. The statement is true. So I was able to confirm it. Okay, so now I plug in the truth value underneath the L because I know that L is false. And since L is negated, it's going to be true. But that's perfect because since this is a conditional statement, and remember that when in a conditional statement, when the antecedent is false and the consequent true, the statement is true. And voila, the argument is invalid. So this is the end. I hope you enjoyed the video. If you have any questions, if you think this was confusing, you didn't understand something, feel free to contact me, and it will be a pleasure for me to explain to you anything that you want to know. I'll see you next time in the next video. Thank you.